Hi everyone, this is a walkthrough solution for worksheet 10. Worksheet 10 solution. Also, if you can let me know if this format for solution is better if I solve and I also explain as I do so. So the first problem says hx is 5 times x plus 2 squared. Find x for which hx is negative 125. So one common mistake here is to plug in negative 125 for x, which is not what the problem is asking. If you notice, it says h of x is negative 125. So you plug negative 125 for h of x. And now you're solving for x. So this is, there's a square involved. So first let's get rid of this number 5. Divide both sides by 5. Negative 25 is x plus 2 squared. To get rid of the square, I'm going to square root. Square root of negative number, we know how to deal with that now. That's 5i plus minus. Finally, I subtract 2, so x is negative 2 plus minus 5i. Okay. Alternate way of solving is open this, file this out, make a quadratic, use a quadratic equation. Lengthier process, you should still end up with the same result. Okay. It says in the following, solve for r. There is not much difference here in problem 1 and 2, except instead of numbers, now you're dealing with letters which represent numbers. So you're solving for r, so the strategy remains the same. Divide by p, just as you divided by 5 here. So a over p is 1 plus r squared. You take the square root just as you took the square root in the previous case, except in this case it's going to remain plus minus square root a over p. And you subtract 1 like you subtracted 2 here. So r is negative 1 plus minus square root of a over p. Now theoretically speaking, this equation represents a compound interest situation, so it would not be negative. But because the context is not given in the problem, you report both the answers. Complete square and solve. Now this was a problem that a lot of you did not do in the correct way. Okay, so I'm not just asking you to solve it, I'm asking you to use a particular method to solve. So you have to use the completion of squares. To do that, notice that's bx, which means I need to somehow make this into a b over 2 squared situation, right? Because that will give me an x squared and a negative 2 times x times b over 2, which is bx. But it also gives me a plus b over 2 squared, which I need to neutralize with a negative b over 2 squared. So this is now x minus b over 2 squared is b squared over 4 plus 2b squared, which becomes a 9b squared over 4. At this point, I can take the square root, which leaves me with a plus minus 3b over 2. Then I add my b over 2 to get x is b over 2 plus or minus 3b over 2. There are more than one ways of solving this. You can factor this as a trinomial using splitting the middle term, but that's not the point. The point was to practice or see that you can complete the square. Same issue with number 4, because it says derive the quadratic formula, which it doesn't say use the quadratic formula. So we're gonna go parallel to the notes. And again, this problem is also supposed to test your completing the square. That's the skill that's being tested here. So I'm going to write this as plus 2 times b over 2 times x plus b over 2 squared minus b over 2 squared plus 1. Again, with the already knowing that this is going to help me write this as x plus b over 2 squared minus b over 2 squared plus 1 equals 0. In addition, which then becomes this, b squared over 4 minus 1, which I take the square root of. If you want, you can write this as b squared minus 4 over 4. You take the square root to get x plus b over 2 is square root of b squared minus 4 over 2 with a plus minus, and then you subtract b over 2 to get negative b over 2 plus minus. So again, this is exactly what you would get if you apply the quadratic formula, but the point of the question was to have you derive the quadratic formula. Just so in case for you to know that you don't really have to remember the quadratic formula, you can always solve by using completion of squares. Next one was fairly easy. I think everybody got that. Write the quadratic equation with these solutions. That means you write x minus 7i, x plus 7i, FOIL it out, x squared plus 7ix minus 7ix plus 7i times negative 7i, x squared minus 49i squared, x squared minus 49 times negative 1, x squared plus 49. The last problem, find the vertex y x-intercept for this parabola. Okay. Finding y-intercept, okay, that's when x is 0. So x is 0, f of 0 is negative 1, so it's 0 comma negative 1. Finding x-intercept is when f of x equals 0, 2x squared plus 8x minus 1 equals 0. Here you have the liberty of using whatever method you want to use to write this as to find the solution. But here basically x is going to be negative 8 plus minus 64 minus 4 times 2 times negative 1 over 2 times 2, negative 4 plus minus 64 plus 8, because the negative times negative is a positive, 72 over 4, which you can simplify. 72 is 2 times 36, so it's 6 root 2 over 4, which if you want to simplify further becomes negative 4 plus minus 3 root 2 over 2. And lastly, you are trying to find the vertex. The vertex is going to be at, so for vertex, again you have the direct formula which you can use, or you can do a completion of squares, and x comes out to negative 2 for the vertex, and f of negative 2 is 2 times 4 minus 16 minus 1, negative 9. Okay, so that's that. Oh, and then there was a bonus problem. Bonus problem is you're trying to find a way of splitting the perimeter. Perimeter is this. You divide by 2. Basically, in a very abstract sense, there are two numbers which add up to 50, and you want to find them so that this is the maximum value, right? Now think about it. If x is, let's look at some values. If x is 0 and y is 50, then the product is 0. That's no good for us. X is 10, y is 40, the product is 400. If x is 20, y is 30, product is 600. So the product takes a bunch of different values, and usually later on when you do calculus, we are concerned with maximizing or minimizing stuff. So here my area function, if I use this equation, I can write y as 50 minus x. So the area now is x times 50 minus x, which is 50x minus x squared. Now remember, what is the definition of a vertex of a parabola? It's this, or this point, which actually is either the minimum or the maximum point in the graph. In this, is an equation which should remind you of a vertex. If I were to complete the square here, I forget the -1, this would look like x minus 25 squared plus whatever adjustment number I have, right? So the vertex would be at x equals 25, which means then y equals 25. And in fact, the area would be 625. Another nice thing here is, what is this kind of a figure called? It's called a square, right? So in fact, you can show in general that if you have a certain length of something which is fixed and you want to enclose the maximum area, then the way to do that is to make a square. Alright, that's it for worksheet 10 solution.